We are going to be talking about taking those next steps within your JavaScript test automation, assuming that maybe you've used a tool to record a test in the first instance, okay, or you're just getting started with writing code from scratch. It's a follow-up to a session we did last month where we went through this from a Ruby point of view, but we're now looking at an approach that will work for JavaScript and TypeScript. And it's really about getting to that next level. Okay, it's about again, if you've recorded a test, it's then about how you can make that test reusable, add value to a kind of a wider team context, keeping your code clean, keeping it low maintenance, keeping it dry, right? The don't repeat yourself principle. So we'll just talk about those next steps, and it is, it's a straightforward journey to get to that point, right? And it then sets you forward on that journey moving forward in your career as a JavaScript automation engineer. And where we get to, we'll look at a very simple flow, but where we get to with this is from our first time recording into a fully fledged page object model, which are the fundamentals of what you need to achieve those principles of low maintenance and reusability and being able to contribute to a team. Okay, so we're going to look at a very simple flow. We always tend to focus on a kind of e-commerce example, so I'm going to come back to Amazon here, right? So, and we'll have a recap on the test evolve recorder in a second, just so you know, or you would know what to expect when you start to use that tooling. But the flow we're going to look at today, so we're going to hit the Amazon homepage. First thing we're going to do is load this page. If the cookie preferences banner is present, we are going to accept that. We're going to clear that. Excuse me. We're going to click into. Excuse me. We're going to click into the search bar, and we are going to look for. Let's have a look. We're going to look for a basketball net. We're going to click on the magnifying glass to undertake the search. Within our automation test, we will assert that we've been presented with a set of results. Okay, that's our first checkpoint, if you like. That's not just pure navigation. We'll scroll down. Let's have a look. We're going to select a product. We'll go for this one here. Okay, we'll select this product. In e-commerce terms, that's then going to give us a product details page, a PDP, as we call it. Before I can complete the purchase on this, there are some sizing options that I need to take account for. So I'm going to click on the drop down. I'll click on this first option. That's going to now enable me to add to basket. So I'll click on add to basket at this point. I'll do an assertion on that product detail page as well to make sure that when I clicked through from the search results, I ended up on the product detail page I expected to. So we'll make that part of my test. Right now, we just added to cart. So I'll do an assertion on this added to basket message here in the center of the screen. So that will be part of our test. And then I'm going to click on the proceed to checkout. And then ultimately, if I don't have a session, I'm a first time user. It will ask me to sign in, of course. So I'll do an assertion on this page to ensure that we are presented with this sign-in modal. Okay. So just as a recap, I am using Test Evolve Spark, which is the underlying automation engine, which allows me to write and run tests, in this case in JavaScript or TypeScript, but also Ruby and soon to be Python. And I'm also using Test Evolve Flare, which is what you see here. So that's the cross-platform studio application that allows me to record tests for the first time. Recording tests, code gen tools have been around for a long time, going back 20 years, to some of the first iterations. Okay, they've been there in order to allow someone who's not written code before to start to build an automated test for the first time, without necessarily requiring a full and detailed understanding of the code that's involved to do that. Under the hood, we're using Selenium WebDriver 4. We are using Cucumber. And in this case, we're using Node version 18 currently. Okay. So just as a quick recap, we've done many tutorials on videos on the recording capabilities of Test Evolve Flare, but just if you've never seen it before, you come into the develop module of Flare. It will allow you to create a new feature. Once you've created a new feature, you can create a new BDD scenario name. Once you have that, you can then create BDD scenario steps within that scenario. Okay, so this is the shell of one that I've just created earlier, and of course we'd write proper BDD steps with a given, when, then format. We always recommend that you keep them short, concise, 3-step format, given, when, then. The given step is always your starting circumstance for the test. Your when step is your tangible user actions to drive the test or the navigation on the application under test. And the then step is ultimately going to be some kind of assertion or verification that you wish to make. As far as the recordings are concerned, when you have created this step, you can just click down here. A browser window will be opened for you. In very simple terms, you can then select your URL here and decide, obviously, which environment, which URL you're going to go to. And then you start clicking around within the application. There's two things you're doing effectively. You're either driving the application by interacting with elements and entering text, clicking on radio buttons, selecting values from drop-down lists, etc., or you are making assertions. Okay, so both of those two things you can do with the recorder as you're doing this thing. So just a very quick example. So I'd hit record here. And if I click on a link, for example, you start to see that the actions are captured on the left-hand side there. I can click on a button here. If you actually obviously record the loading of the page, it will record that as well. And if I wanted to assert that something was displayed on the page, so using the Selenium is displayed method, then I do a right click here. I have an element verify option, and I can just click on displayed, for example. Okay, so that's just a 30-second overview of how the recorder is used. It's the only product out there currently that allows you to record either JavaScript, TypeScript, Python, or Ruby directly into a Cucumber BDD style automated tests. We have that direct integration there. All right, that's just a recap on how that recorder is used. Okay, so the journey that I just walked you through on the Amazon website, so I recorded this earlier. Now we start to have a look at what's actually generated. Okay, so we will have had a new feature that was created. Let's just find that first of all. Here we go, e-commerce checkout feature. So in the recorder, when you create a feature, it's going to build the skeleton of that feature in that scenario for you. So feature, e-commerce checkout. I've also added a tag in this case. The scenario that I would have created through the recorder was an Amazon website checkout. I then created 3 steps, a given, when, and then step. All right, so given I go to the Amazon website, when I add a product to my cart, then I can begin my checkout. So that was the exact flow that I manually walked you through on the Amazon website. All right, so what the recorder is going to give you once you start recording that journey is something like this. Now, as you're using the recorder, and again, this is unique to Test Evolve Flare because we are working within a BDD scenario. As I move through my given, when, then steps, and I'm recording my journey, when I've satisfied the criteria of the given step, so in this case it's just going to the Amazon website, in the recorder I then click on the when step and just continue my journey, and all of the subsequent code that is recorded will be inserted within the when step, as you can see here. And then likewise, when I'm ready to move on to the then step, I open that and just continue my navigation within the browser within Flare, and that code is then inserted within the then step. So it's always interacting with the file system. Okay, so that's how it works in principle. But the key thing now is to show you some of the code that's actually generated typically. Okay, something to note here, of course, Test Evolve Spark with support from Flare, like some other tools, is what we would probably call A code gen or a code accelerator, it's a low code solution. It's definitely not no code, because clearly you are presented with your code at the end of this recording process. Other tools, usually SaaS-based tools on the market that are no code solutions, will allow you to record tests, but that code is ultimately tucked away, never to be seen again, hidden up in the cloud somewhere. So this is a type of product where you have an accelerator to record your test, but you very much are presented with the code to refactor as you move on with that test. Okay. So in terms of the code that was generated, so we did a few things, you'll recall. So we loaded the home page. JavaScript is asynchronous, of course. So what it's going to do, we have to wait for each of these sequential steps to complete. Okay, if we don't tell them to await, we're going to experience all of these race conditions. But so again, not something, if you looked at the earlier example with Ruby, it's not something you need to do. But with JavaScript, we are awaiting these steps to complete. Okay, so we load the page. You'll remember the next thing that we did. If there was a cookie preference banner present, then we clicked on that, we accepted those conditions. Okay. I then moved into the when step because the given step had been satisfied. The when step is about adding a product to cart. Now that consisted of a number of different things. And you start to see here it gets a little bit busier. All right, it's not as immediate, what's actually happening here. We can go through it because we can recall the journey on the site, but let's look at that. So first line of code here, we clicked into the search box. All right, so that's literally a click into the search box. And test evolve flare is generating that code as you record your tests. All right, so it knows it's a text field, it picks up and it uses the ID of that text field as the locator strategy for that element. And then we called .click on that. All right. The second thing we did was to set some text or our search term. So we set basketball net as our search term. The next thing we did was to click on the magnifying glass. That then executes your search. All right, we're on the results page at that point. And as I said, when we navigating through the user flow on the website, we're going to use that opportunity to make our first assertion. So we were going to assert that by executing a search, I do in fact get presented with some results. So in this case, the recorder has picked up that I'm looking for a span. It's used an XPath reference in this case, looking for text of results. Okay, so it's simply saying if that is not displayed, then throw a new error. So that's how the recorder will generate basic assertions for you. The next thing we did was to select a product from that results listings page. Now in this case, when you're looking at the Amazon results pages, there are many things from a product point of view that you can click on, and within a product window, you can click on the image, you can click on various attributes of the product, the main product or the link text, which in this case is what's been used. So we made that product selection with the use of link text. So find element by link text. And you can see here that this was really the big description that we used, and we called .click on that. Okay, so that then loaded the product detail page. You'll remember we have another assertion here. So we wanted to know that we had definitely been taken to the product detail page, the PDP, and it's generated a line of code to do that. Okay, by looking for a div with a title section ID, and again using this information here. If it's not there, then throw an error. Okay, so then moving rapidly through, we had to make a size-based selection for that product before the add to cart was enabled. So we did that there. And then when that was enabled, we clicked on the add to cart button. That's the code that's been generated for that. We then said that we wanted to verify that that add to cart had been successful, and we were doing that by asserting on the added to cart or added to basket message. So there's a particular div with an ID here that we are making sure is displayed in order to be sure that that's happened successfully. Now at that point, all of that stuff we've just been through constitutes the adding the product to cart. So the when step has been satisfied at that point. I then would have expanded the then step within the recorder and continued with my last few checks. So this is about beginning checkout. Well, beginning checkout consisted of clicking on the proceed to checkout button. There's a couple of things I did. I made sure that it was displayed first of all. So that was, if you like, a third checkpoint in my test. In my end-to-end checkout flow, throw an error if that proceed to checkout button was not displayed. Once that had been verified successfully, we then actually clicked on the proceed to checkout button. And then finally, we wanted to make sure that by doing that, we were presented with the sign-in page. So effectively as a guest user or a first-time user on the Amazon website, who didn't have a session, I should be presented with the ability to sign in. So this was a final checkpoint, a fourth checkpoint or verification, if you like, within the test that's been recorded by TestEvolve Flare in this case, that I am presented with the screen and the field within that modal on the screen that would allow me to sign in. So that's my final checkpoint, my final criteria to satisfy my then step. Okay, so that's the code that is typically recorded. Again, we're looking at a JavaScript example, of course, but by any tool that is going to allow you to record tests, generate code on your behalf. Without any reference to the page object model at this stage, this is the kind of thing you're going to see. Okay, so that doesn't take long to record that. You'll do that within a minute, 2 minutes probably. But that's the code that's generated. All right. So let's start to consider what's not so good about this. So yes, it is an accelerator. But what it doesn't leave you with, it leaves you with a first step on the ladder, if you like. But what it doesn't give you with is optimized, low maintenance test automation code in the language of your choice, JavaScript in this case. Right. So what are some of these limitations then? So code that's generated in that way, again, it's an accelerator, but it's definitely not dry. Right. It doesn't follow the dry principle of don't repeat yourself. Let's imagine you've got 3 people on your team, all using this kind of recording approach to generating their tests for the first time. If they all start with the concept of hitting the home page and executing a search, you are going to have both element duplication in multiple places. So the search bar, the magnifying glass, search execution button, maybe the results header on the results page. The elements for these that we were using are going to be generated and duplicated in multiple tests that have been recorded by multiple people on your team. Okay, so if any of those elements change or break, you then have this issue of needing to go and fix these tests in multiple places. All right, there's element repetition. And what you're also getting is snippets of the user journey that are being repeated in multiple places as well. So none of those things are optimal at all. For Cucumber-specific based frameworks, of which we are one, you'll see that the steps, I'm going to say they're not optimized for readability. All right, so if I come back here, what I mean by that is that I can see the code that's been generated, but I really have to kind of go to a low level to analyze each line of code. To, in my mind, if I wasn't the person that recorded this test, and I was reading through this, I'd have to read through it very, very carefully to figure out roughly where I was in the application and what was being done. We're clicking on things, we're setting text, we're raising assertions on things. So it's just not especially readable at this level to anyone other than the person that recorded that test. Again, so if you were to check this into a source control and the other 2 people on the team were to look at this code, again, it's not optimized for reusability in that sense. Okay. In this format, it also doesn't relate to the structure of the application under test at all in any way. If you think what we did when we looked through the journey on the website, we hit 3, 4, 5 different pages maybe on the Amazon website: the home page, the results listings page, a product details page, and certainly we landed on a sign-in page as well. Now there may be more, if it's a longer journey, there may be a customer profile page, but those are the kind of constituent parts of the application, the web app under test. And our code in this format doesn't relate to those pages. It doesn't relate to the processes, the user processes on those pages, like searching for a product, that we were undertaking. Okay, all it's really doing is relating to individual elements at this stage and the thing that you're doing with them, either clicking, setting, asserting that it's displayed. So there's no relation between your code and the application under test at this stage if you were to never refactor this code. All right, so that's not an optimal thing either. Clearly very, very hard for anyone else on your team to reuse this code. The only option people have at this stage, especially again if it's a Cucumber-based framework, someone could reuse a given step or a when step or a then step. If they were confident that what they could see in that given when then step did exactly what they needed it to do for their test. That in theory works, but the main problem with that is that it absolutely flies in the face of what good practice BDD scenario creation is all about. Okay, we shouldn't be going out of our way to reuse steps in Cucumber tests. If you followed the process properly, there would have been a 3 Amigos session. Developers, testers, and product owners or business analysts would have been sat there defining stories, scenarios, given when then steps. And when it comes to implementing the automated tests to support those, they should honor the scenarios and the steps that came from that 3 Amigos session. They shouldn't just be reusing given when then steps from other tests because it's convenient to do so. That's not what good practice BDD and associated automation tests, that's not the spirit of how it should work at all. So really at this level, there is no team reuse of your code. When it comes to then running these tests, and in fact, let's do that now just to show you what that test runs like. If this test were to start failing at any point, for any reason, all you're going to get there in a stack trace is reference to an element and something that either couldn't be checked, couldn't be clicked, text that couldn't be entered. You're just going to have reference to the Selenium test effectively failing at the element level in the place in which it failed. And what that doesn't give you is any context of really where you are in the wider test or the user journey, the process flow. You don't immediately come to understand where and why that test may be failing. You'll simply see, for example, that maybe WebDriver was unable to complete the click on this element. Now, in the confines of an end-to-end test flow, that gives me nothing to go on. I don't really know where I was in the journey unless I've really come to understand this code at a very low level. Okay. So yeah, failing stack traces are not linked to pages or processes, only elements. And the net result of all of this, of course, as and when things do start to fail, right? Things will, because as the application changes over time through your sprints, the front end will change, elements will become brittle, they'll break. So your maintenance will go up. You're going to spend more and more time and effort. Your tests will devalue over time because they're not going to be able to be relied upon to give you that quality oversight of your application. To the wider delivery team, to your stakeholders, the confidence in both the testing practice and the service that they provide with the test automation is going to start to dip. Your delivery may start to slow, but ultimately your automation, your testing practice is not optimized and it's not doing its job. Okay. But to get to the next level is not that big a jump, right? And that's the whole purpose of what we're talking about today, and what we talked about last time with the Ruby example. All right, so what we're going to look at now is how I take that recorded journey with given, when, then steps, and I start to package it into something that is dry, that is reusable, excuse me, and does respect excuse me, the page object model. All right, so let's have a look. So I've now got 3 layers to the framework. I've refactored at both the feature level but also the checkout steps level, and we've added a 3rd layer to the framework, which will be the introduction of pages, okay, to support this implementation of the page object model. We add pages to a project because it mimics the structure of the application under test. So we described in our test how we moved across the home page, results listings page, a product details page, and a sign-in page. So in terms of implementing a page object model, I'm going to add equivalent pages to my automation project. So within the framework, I have a pages directory. When you open up a new Spark project using Flare to do that, we will give you example tests. So you already see what an example page would look like. So I've gone along and added 1, 2, 3, 4 representative pages in my automation project for the pages of the application under test that my test moved through or covered off. So we have a home page, a results page, then we saw the product detail page, the PDP, and then finally we landed on the sign-in page. So when you have an example project, you can just copy this page here. You can drop it in the same pages directory. And then if I'm working on the Amazon homepage, for example, I will need to refactor this or name this page class appropriately. So this is Amazon Home. And then likewise, I will do the same for the results page. So we've got an Amazon results page here. So it actually extends our page object model within Test Evolve Spark itself. And we do the same for product details page, PDP, and we do the same for the sign-in page. Now, the next thing I'm going to need to do, there'll be an index.js file within that pages directory. I need to add these new pages in that index.js file, and I simply do it like that. So export default as, and then the name of the page, Amazon Home. This is how we are going to refer to it within our mid-level step definitions. So Amazon Home, Amazon Results, Amazon PDP, Amazon Sign-in, and then we add the appropriate file from which we are exporting those. All right. Just so you're aware, within the env.js, it's going to take care of that page-by-page initialization for you. So within this file, and this is one of the first files which is really executed within that Cucumber testing cycle, it will import everything from the pages directory, and before any tests are run, it will initialize each of these new pages that we've just created, all right, as long as they are on that index.js. So that's the first thing you're going to need to do. The next thing I do, I think about that journey that I recorded, and I want to start breaking down parts of that journey into what I would then clearly define as user actions. Now, it all started on the home page. So what I mean by that, the first thing we did was to go to the site. The first thing we did was to clear the cookies banner. Okay, so that becomes a method or a user process, if you like, a chunk of functionality that I'm only ever likely to do from the home page. So I make that a method, a dedicated method on that particular home page that I've just created. All right, and so I then start to consider the logic there. So rather than just trying to blindly click on that element, I'm saying if it's displayed, then I can click on it. If I try and do that, I can also catch an error. in the event that I'm unable to click on it, and I can throw a message just to say, well, that banner was no longer on the page, continue to the next step. So it has some robustness to it as well. But what you're going to now start to see as well, that it is no longer the element or the specific element reference that was recorded. All right, the thing that was recorded was this bit up here. All right, so what the page object model is going to tell you to do is to create these elements as page objects on the page that they exist. So we're on our home page. We are identifying elements and chunks of functionality that only exist on that page. So that cookies acceptance button is on the home page, and my new method to close that also exists in the home page within my automation project. Now I've used the same identifiers that the recorder captured. I've just turned them into elements. So I've decided to call that a cookies banner. And I've given it the locator strategy that the recorder gave me when I recorded the test. So it's declared it as a submit, and it's used the ID attribute of SPCC accept. I've then repeated that for the other elements that I interacted with that are on the home page. So I had a search text field and I had a search submit button. So at this stage, this is me declaring my elements on my home page in my automation project. And the reason I've done that is because the second thing I did on that page, albeit it wasn't in the given step, it was in the when step, which we'll look at in a second, I searched for a product. Okay, so let's just come back here. So you'll now see that on the given step, we did two things. We went to the site. I've actually parameterized this. So at the feature level, one of the things I've been able to do is start to do some parameterization by injecting some of this data. So it's not so much hard coded now. Anything that you record with any kind of code gen tool will effectively be hard coded. But I've moved that parameter, the URL in this case, up to the feature level, and I've stuck it as part of the given step. Given I go to the Amazon website, it's actually going to read in this value. Okay, so that's passed through as something called site as an argument, and that argument is then used within the goto command. But now you see that in my given step, I'm now making reference. I still have to await because it's asynchronous and I need it to complete successfully. But I now reference my new page class, the Amazon home, and I now reference a specific method or function on that page class. And what you start to see generally within your middle layer, now very much this is unique to a Cucumber-based framework because you have this step definition layer. But what I now start to see, the kind of the inner workings of these given when then steps become very, very readable, right? So, you know, our view at this level would always be that your step definition file, this whole thing, should effectively read like a kind of manual testing script. So I go to the site, I clear the cookies banner, I search for a product, I assert the results page displayed, I select a product, I assert the product detail page, I select a product size, I add it to cart, I proceed to checkout, and then I assert the sign-in page. So you start to see now that even though this is the middle layer of the framework now, so we always refer to the feature as effectively the business-facing layer of a Cucumber automation framework. These are the scenarios that would have come from your 3 Amigos sessions, your discovery sessions, so they will mean something to everybody in the organization connected with the delivery or people that are designing your application. That will be very, very clear. The second level down, or the step definition layer, if you like, is a little bit more detailed, but it should still read, as I say, like a manual testing script. So if someone understands the application, this will still make a great deal of sense. Okay, so our given step just referenced the home page and the closed cookies banner. When I was recording the journey, we then moved into the when step, and I was searching for a product on that home page. So the first step within our when step now is the searching for a product. This is still on the home page. These are all, of course, I can navigate through. I can click into these. So I have this second method on my home page, which is called search for product. I've allowed it to receive an argument, which I've called search term. And it's now using these elements that I've declared at the top of the page class. So a search text field and a search submit button, which are up here. Okay. And I have this search for product method. It's going to click on the search text field. It's going to set the search term, which has been passed through as an argument. And then it's going to click on the search submit button. So that is a unique pocket of functionality, if you like, the searching for a product. What this then becomes is a reusable piece of code or a method on that page class that anyone else in my team can use. And this is how the team will start to work going forward. You know, if they know, they'll see here that someone has created a home page class, a product details page. So when they're coming to writing tests of their own, as you mature as a team, as an automation engineer, you're likely to move away from the recording of tests. You're going to start to code from scratch. And the way you ordinarily do that is to look and see which pages already exist within your automation project. You, as a tester, as you get more and more familiar with the application under test, you are going to know the types of user actions and functions that you can perform on certain pages of the application. So if I want to understand if, for example, someone has already created or written some code to search for a product, then I'm not going to go to the results page to look for that. I'm going to go to the home page, because that's ordinarily where that search for product would be initiated. And sure enough, when I come to that page, I can see that someone may have written a search for product method. And this is how we start to create these building blocks that we can then refer to in the same way as we go forward. So I might have written another given or when step, and I could immediately then use this call to Amazon Home.search for product. I wouldn't have to worry about trying to make reuse of this when I add a product to cart method if that wasn't exactly the sequence of things that I wanted to do. But if at some stage I did need to search for product, then that unit of code, that block of code now exists for me to make reuse of when I'm building out a new test for the first time. And this is the element of reusability, transparency of code, and how other people in your team can make use of these building blocks. All right, and that's one of the fundamental benefits of this page object model. All right, so let's move through. So we've just searched for product on the Amazon Home. Let's look at this in a kind of consolidated manner. So we created an Amazon results page. There were two things we were doing there. We were asserting that that results page is displayed, and then we were selecting a product. So I can click through either straight into the page class itself or directly into the method. This pattern is repeated now. All right. If I come on to the results page, what you'll see here is elements that have been defined. So again, this was how the recorder recorded a particular element, and in this case I was recording an assertion that it was present, but nonetheless this was the locator strategy it used. I've now decided to call this the results page header, and rather than just having this line of code in my step definition layer, which again might be a bit too granular, it's more transparent, it's more reusable if I create a dedicated method to do the thing that I want it to do. Right? The thing that I want it to do is to assert that the results page has been displayed, and then I still use the recorded code that I was given. I've moved it inside this method, but rather now than referring directly to this XPath location strategy, I now just refer to the element name that I gave it. So I'm simply saying, if my results page header is not displayed, then I'm going to throw a new error. What I'm also going to do as part of putting this page object model together is make my error messages that were recorded a bit more specific, a bit more meaningful. So now I'm working with the idea of a dedicated page element. I can include that within my error message. So in this particular error, I can make my error message, if that error is thrown, that my results page header was not displayed on the page before timeout. So I can start to customize my error messages now to make everything more readable, more usable when the tests are actually run. Okay, so just coming back to our checkout steps, we did two things. On the results page, we were asserting that that results page was displayed, and then we were selecting a product. Okay, now you probably see here that we're also working with another argument in a different format as well. So if I come back to my feature level, I decided that what I wanted to do was to more dynamically pass through some arguments to be used. So there's two things. I've got a search term, so this is going to be used for the searching of the product. So it's going to search for basketball net. And really what it's doing by doing this, it's lifting up some of these things that were previously hard-coded when they were recorded as a test, bringing them to the surface at the business-facing layer of this Cucumber-based framework. And it makes it a visible, transparent part of the test. So anyone looking at this scenario, they see the URL we're going to, they see the product search term that's being used, and then we have reference to this other thing called item, which we can now see as this longer description that we were working with. So this is all within the when I add a product to my cart step. So I click in there. And we were working on this results page, so we'd created a select product. And this is the argument reference that I can use. So really what I'm doing with this when step, I'm passing through the entire table, which consists of 2 columns, 2 rows, and I'm saying work with the first row and refer to this thing called item. And in this case, the item is this entire string down here. Okay. So that's just one way I can work with Cucumber-based tables in a feature. So let's look at that select product method. So it is just that. It's a new method on my results page class. And in this case, I've chosen just to show how you can still use the element that was recorded by the test. So you don't always, it's good practice to, but it's just to show that in an isolated method, you can have an isolated line of code. So it's still only one place you would have to go to fix this if you had to. But in this particular example, I haven't created it as a page element up here, but it is isolated and it is unique in this one single select product method. So this select product method, I allowed it to receive an argument, and I've actually used that as a way of giving WebDriver a dynamic link text element to search for. And you'll recall that we were passing through the product description, in this case as the link text that I want to click on. All right. So moving quickly through, at that stage we're still within the when step, which is about adding a product to cart, but we then start to move on to a new page in the application. At this stage we're on the PDP, the product details page. We're doing 3 things as far as a user process concerned. We are asserting that the product detail page is displayed. And again, we're using this reference to the product item there as well. We're selecting a product size and we're adding that product to cart. So let's go and have a quick look at those. We've got more elements on this page. So I've taken the elements that were recorded within the test and I've turned them into sensibly named elements that I will be able to refer to in the future, my team members will be able to refer to in the future. Not only can they make reuse of these blocks of code, these methods that exist, they can of course write their own methods on this page class, but at that level they can make reuse of the elements that exist. So it's all about reuse. Either you're reusing individual elements themselves in the creation of new methods, or you're reusing the call to the page class and the elements on that page class within your Cucumber step definition. So it's reusability at 2 levels in that sense. All right, so I've created 1, 2, 3, 4, 5 elements. I kept the elements, the WebDriver locator strategies as they were recorded. But I've created a product header, a product size option, an add to cart button, and an add to cart success message, and a proceed to checkout button. So all sensibly named elements that are then referred to in these methods on these page classes. So the first thing we did, we were asserting that the product detail page was displayed. Well, that was a checkpoint that was recorded in the test. So unless this product header, in this case I'm actually extracting the text of it, I'm passing through an argument which again came from the table. Okay, that was our product description. I'm saying now, unless the text of the product header matches the item that I passed through from my table, then raise an error. This is a great example of how I can inject some of those arguments and text extractions into my error message itself. So I've gone to town on this one. So I've said I expected the product detail page product header text to be, and then my expected result. And that's how I can inject my expected result into an error message. I was expecting it to be that. In actual fact, it was, and at that point, I can make reference to the WebDriver extraction of the text, so I can inject all of that into a really useful, very readable error message if my condition here is not met. Okay, so if the header text on the page, the actual header text, is not equal to the expected item that I passed through from the feature and scenario table, then throw a very dynamic, readable error message. Okay. We selected a product size, so that was simply an element click. So I defined that element here, the product size option. There we go. That's this guy here. So that was a simple dot click. We then added product to cart. Two things I was doing there. I was clicking on the add to cart button once it was enabled, once I had selected a size. And then I wanted to make sure that that add to cart had been successful. So you'll recall that we were looking for a success message saying added to basket. And again, I've just made that error message. If that condition is not satisfied, I've made it very readable. So the add to cart success message was not displayed on the page before timeout. Now, if you define your elements with very sensible names, so add to cart success message, it's really easy to then, that's the condition that needs to be satisfied. If this add to cart success message is not displayed, it's going to throw a new error. I may as well use the name of that element in my error message. So absolute transparency. But that is only really going to work if you sensibly name your page elements. And finally, I proceeded to check out. So two things. I made sure that it was there, first of all, and then I clicked on it. And I've done the same thing here with my error message. I've used the element name itself. So proceed to checkout button was not displayed on the page before timeout if this condition is not satisfied. All right, so perfectly readable, and that was everything we did on the PDP page. Coming back to our checkout steps, so that has really taken me through this half, the second half of the when step, if you like. We've added our product to cart, excuse me. And then finally, when we were recording the test, we were opening up the then step and satisfying the criteria for that. So that was all about beginning the checkout flow. As far as the actions we recorded on the Amazon website were concerned, that consisted of two things. That consisted of proceeding to checkout. Well, actually, we've just covered that one there. So really, it's only one final thing that warranted the creation of a fourth and final page, which was the Amazon sign-in page. And we were doing one thing there. We were asserting that sign-in page was present. So actually, as we step into this sign-in page, we're going to see that this is really quite lean. There's not much going on here at all. We have a single element. So again, sensibly named sign-in email field. Again, this was the element or the locator strategy that was recorded by Test-Evolved Flair. So that's fine. We keep that. We just give it a name that we're going to refer to. I create this method. So this is the assert sign-in page method that exists on the Amazon sign-in page. And this was simply a checkpoint, a verification to make sure that this sign-in email field was displayed successfully on the page. And again, I've done the same thing. Sign-in email field was not displayed on the page before the timeout. All right, let's just run that test. You'll see that it works in exactly the same way. And what I want to show you as well, we'll look at it afterwards, but some of the debugging information that you get within Test-Evolved Spark as it's working through, running the test, looking for elements. We do a number of things under the hood that mean you don't need to do it programmatically. Okay, so you don't need to tell WebDriver to wait for an element to be visible or for it to be enabled. Okay, we do all of that for you. So when that test is being recorded, and when we are instructing WebDriver to move through the browser, we have our own API wrapper that orchestrates the intelligent waiting for these things to be in the right state. So that test was successful. We can see that. One scenario passed, 3 steps were passed. That took 20 seconds, and we closed the browser at the end. Excuse me. Just going to the back to the beginning of that. While I run this in debug mode, you can see exactly the configuration that was used. So I did that with Chrome. It was maximized. I wasn't using any specific viewport settings, etc. So it tells you a little bit about the way the test is being run. But it gets more interesting here with these browser steps. It starts to say, right, what was I trying to do? So the browser navigated to amazon.co.uk. Okay, that took 3.2 seconds. The browser, we were instructing the browser to click on our element called the cookies banner. Okay, and what you see when you have debug switched on is that it finds the element cookies banner, or sorry, it starts by looking for it, and then it confirms that it has found it. Now that alone is not enough. We want to check the state, and this is where, if you are doing an entirely open source WebDriver project, you would have to create these things programmatically, but you can see within Testafel Spark that we have these clever preconditions, these intelligent conditions. So we are waiting for the element. It finds it, but it then waits for it to be visible. That step passed after 0.04 seconds. And then as a final check, we are also waiting for it to be enabled. All right, so we do that on your behalf. You don't have to do that. And that step took 0.09 seconds. Okay, so as you move through, you can again follow your step through everything that's done. Looking for the text box, clicking on the search submit button. There is the step where we entered our search term. All right, found the search submit button. Clicking on the sizing option. Adding product to cart, click on the proceed to checkout button, etc, etc. So if you do run your tests with debug switched on, you not only get a measure of timing and how long things took, but you get an absolute audit of how that test ran and what it's trying to do under the hood for you. Okay. So just as a final recap, what did we do to refactor this to implement a true page object model? Well, the fundamental thing we did was to introduce a third layer, which was the idea of pages. Okay, we added as many pages as pages of the application under test that we moved through in our test. We created unique user processes or page processes on each of those pages. Each of those methods on those pages used sensibly named page elements that we defined. We used the locator strategy that the recorder gave us, but we renamed them into something that was more readable. We then also made reference to those page elements in specific error messages as well. The net result of doing all of that is that when you look at your step definition layer, you look at your given when then steps under the hood, you have what we would term to be effectively a manual testing script. So even though this is the second layer down within the framework, it's still very, very readable. What we started to do at this level was to introduce some feature or scenario level refactoring as well. And really what I mean by that is that we added the ability for people to start to inject data or parameterization into this test. All right, so we injected the URL and we injected a search term. And we injected an item that was then used both for actually driving the application with that specific clicks on links, but also to assert that we are on the right product detail page, for example, because that was the text within a div that we were verifying. Okay, so that's really it. You know, that's how you take a recorded test that can be a little bit ambiguous and high maintenance and unreadable to other people, and how you refactor it into something that is very reusable, very readable, and very robust moving forward. So if I'm on any of these pages, if something about this search text field or the locator strategy of it, if something about this were to change, and in your application that may be very likely, you've got a single place to come and fix that. Okay, so it's very, very dry in that respect. It's very reusable by your teammates. And as you, over a number of sprints, you're going to build more and more pages. These pages are going to reflect the different pages within your application under test. You're going to define the elements on those pages, and as a team you're going to start to build up this library of reusable methods on these page classes, and you're going to find that your ability to write new tests from scratch, making reuse of these blocks of code that already exist, accelerates your automation effort significantly, and that's the ultimate objective here. If you found that useful, please consider giving us a like, a thumbs up, a subscribe. Keep checking back for new content. And if you're looking to explore those next steps on your automation journey, then look us up. Download our evaluation, fully featured version of the product, completely free of charge for 30 days, and just see how quickly you can make some immediate progress. Okay, so until next time, we'll see you then.